Hey everyone, and welcome. Today we're going to tackle a really interesting question, one that seems simple but is actually super deep. Is the matter all around us really pure? Let's find out.
I mean, think about it. That glass of milk you had this morning, or the salt you used for cooking. The package probably even has the word pure written right on it. But, from a scientific point of view, is it?
Okay, so this is where things get a little tricky. The word pure is at the heart of it all. See, in our everyday lives, when we say something is pure, we usually mean it doesn't have anything bad mixed in, no additives. But for a scientist, pure means something way more specific. It means a substance is made up of only one single type of particle. That's it.
And what that means is all the stuff we think of as pure, like milk, which is actually a combination of water, fats, proteins, and more, or even things like seawater or soil, they aren't pure at all in a scientific sense. They're actually what we call mixtures.
So here's our game plan. We're going to really nail down what pure means to a scientist. Then we'll look at the big difference between mixtures and pure substances. We'll dive into 3 cool types of mixtures and then check out the real building blocks of matter. We'll finish up by figuring out the deal with mixtures versus compounds. It's going to be fun. Let's jump in.
All right, so think of this as the first big decision point when we look at any kind of matter. Everything, and I mean everything, can be sorted into one of 2 big buckets. It's either a mixture or it's a pure substance.
So, what's the actual difference? Well, a pure substance, like sugar or salt, is made of just one thing, right? You can't separate it into simpler parts using physical methods like filtering or boiling. But a mixture, like salt water or the air we breathe, is just 2 or more pure substances hanging out together. And here's the key. You can separate a mixture using physical means. You know, like boiling the water away to get the salt back. Simple.
Okay, now that we know what a mixture is, let's zoom in a little closer. Because you see, not all mixtures behave the same way. We're going to check out the 3 main types you'll come across: solutions, suspensions, and colloids.
First up, we have solutions. A solution is what scientists call a homogeneous mixture. Now that's just a fancy word that means it's perfectly uniform. The particles are mixed in so well, right down to the microscopic level, that you just can't see the different parts.
So what makes a solution a solution? Well, for one, it's completely uniform. The particles are so incredibly tiny, a beam of light will just pass straight through. It's also super stable. Once you mix it, it stays mixed. The parts won't just settle down at the bottom. Think of lemonade or soda water. Even solid metals can be solutions, like brass. Now, let's talk about something totally different, a suspension. This is a heterogeneous mixture, which basically means it's not uniform. You've got solid particles just floating around in a liquid, but they never actually dissolve into it. Unlike solutions, you can totally see the different bits in a suspension with your own eyes. And because those particles are bigger, they'll scatter light if you shine a beam through. But, the biggest giveaway for a suspension is that it's unstable. Just let it sit for a while, and all the particles will eventually sink to the bottom, kind of like chalk powder in water.
And now, we get to the really fascinating one that's kind of in between, the colloid. In a colloid, the particles are bigger than in a solution, but they're still way too small to see with just your eyes. They look like they're perfectly mixed, but there's a secret.
This is what makes colloids so cool. They're like little tricksters. They look homogeneous and uniform, but scientifically, they're actually heterogeneous. And here's the awesome part. While you can't see the particles, they're big enough to scatter a beam of light. This really cool phenomenon has a name, the Tyndall effect. And just like solutions, they're stable. Our friend milk is a perfect example of a colloid. And you've definitely seen this in real life. It's actually beautiful. Have you ever been in a forest and seen those amazing beams of sunlight cutting through the morning mist? That's the Tyndall effect. The misty air itself is a colloid, tiny water droplets suspended in the air, and they make the path of the sunlight totally visible. So cool!
Once you start looking, you'll realize colloids are everywhere. It just depends on what's mixed in what. Got tiny liquid drops in a gas? That's an aerosol, like fog or clouds. Gas bubbles in a liquid? That's foam, just like your shaving cream. And milk and face cream? They're a special type of colloid called an emulsion, which is a liquid mixed in another liquid.
Okay, so we've pretty much covered the whole world of mixtures. Let's backtrack a little and go down that other path, pure substances. These are the real fundamental building blocks, and they come in 2 main forms, elements and compounds.
Let's start with the most basic of the basic, an element. An element is a pure substance at its absolute simplest. You can't break it down any further with a chemical reaction.
Think of them as the Lego bricks of the entire universe. And even these Lego bricks come in different types. The ones we're most familiar with are metals, right? Things like copper, iron, gold. They're shiny, they conduct heat and electricity really well, and you can shape them. And then you have the non-metals. These guys are poor conductors and come in all sorts of forms, from the oxygen gas we breathe to solid carbon in your pencil.
So what happens if you take 2 or more of these element Lego bricks and you don't just mix them in a box, but you actually click them together chemically? Well, then you get a compound. The 2 most important things to remember here are chemically combined and fixed proportion.
You know, this difference between just mixing things and chemically combining them is so important. To make it super clear, let's imagine a little experiment with some iron filings and sulfur powder.
Okay, imagine we have 2 groups. Both groups start with the exact same things, iron filings and sulfur powder. Group 1 just mixes them together really well. But Group 2, they mix them and then they heat that mixture up like crazy until it's glowing red hot, and then they just let it cool down. And what happens? The results are completely different. For Group 1, you just have a mixture. The iron is still iron, the sulfur is still sulfur. You could literally pull the iron out with a magnet. But Group 2, whoa. The heat caused a chemical reaction. They've created a totally new substance, a compound called iron sulfide, and it has completely new properties. The biggest clue? A magnet won't work on it anymore.
So let's just boil it all down one last time. In a mixture, the parts are just hanging out, keeping their own identities. In a compound, the elements have reacted and become something brand new with its own unique properties. And the ultimate test? You can separate a mixture physically, but to break a compound apart, you need another chemical reaction.
And there you have it. We started with a simple question about purity, and we ended up with this amazing system for classifying everything in the physical world. It's like having a new pair of glasses to see everything around us. So, I'll leave you with a little challenge. Right now, just pause and look around you. The air you're breathing, the water in your bottle, the phone in your hand. Using what we've just talked about, can you start classifying the matter you see? Give it a try.